Oh my god, somebody's actually back here, guys. What's going on? Memes here. And yes, as the stream title describes, this is a working session for my Wolfram summer school project based upon units. So what we're doing right now, here's the general messy outline. Here's some stuff that Richard had sent me about the current SI base units that the second part is going to be the analysis. Right now, I'm just putting together the abstract and the outline for the intro and basically the first half, going through the history, as I've already reached out to Rick and Thad, and they've given me a bunch of information to kind of go through. So now we're just going to basically start to notate, find actual sources, and do the layout. AKA, I have about an hour or so until our next session. Um, and I'm just gonna do that right now. So I apologize if I'm worse with our friends in the chat as of late, but let's just go through this real quick. So we have our base 7 SI units: the kilogram, the meter, the second, the mole, the ampere, the Kelvin, and then the candela. I am not alone in the sketchiness of the candela and the mole. They may have certain places, but I believe we can count. I believe we can count number one, and then luminous intensity just sounds like you could express that as temperature and then basically meters squared, or just an energy density, something like that. So, but I will digress. Um, Okay, so some things like dose equivalent that basically you have in medicine and stuff. It's like lethal dose and stuff. We're not really going to do much on that. We're basically going to focus on the primary units that we have: length, time, mass, ampere slash charge. I'm going to make the case for charge being perhaps the better one, as well as temperature. Um, Basically, you only have about a week or so to work on this, so really just need to investigate this, go through the history. I'm going to flesh it out this weekend, and then we're going to do the fun stuff next week where we start to actually try to look into what might actually be going on and see if we can make some connections to the Wolfram Physics Project. I'm going to stop talking right now because I have a habit of just not doing what I'm supposed to do and asking other questions, and occasionally you find something where you're like, that is very shiny. But I digress. Okay, so how do we get here? Dugan went over some of the base Wolfram Physics project with me. Now I can actually start to play around, i.e., it's like Xerxes said, just play with code. Okay, so essentially we started off with human reference of units. Basically, the OG qubits were basically the pharaoh's forearm to like the tip of their finger. Now that may have worked for a while. The problem is pharaohs end up dying. They end up passing away, and you have a new pharaoh who, unless they're an identical twin, you're probably going to have some issues. And even with the imperial system that you had within Great Britain and everything, hands and feet, and that would change. And then, well, to be fair, we still use imperial units over here in the United States. Why? Because our unit of distance should be based on a deceased monarch's shoe size. Because we can. All right. Okay. That was ChatGPT trying to help me with some other stuff there. We're going to do a much different diagram. And then we'll schedule some stuff for next week. All right. So we can undo that. All right. Hey, Jedi. Good to see you, my friend. No, I'm just putting together my little project here, and anybody who wants to tune in as I boringly go through this so I can actually have something to show my mentor that's hanging out there in a couple hours, we will do that. I'm one of those bad procrastinators in that I have so much in my head, and I kind of write things in my head, and then I actually just need to put it into the actual thing. So let's go over here, go to our units project. All right. So current tentative title, units. Now we got her and methodology and Wolfram physics. All right. So quick little abstract. We explore the history of units and their transition from human-based measures to more concrete well, let's say a more substantive basis. Okay. So, like, for instance, a carrot, kind of like that we use for gems and stuff, was actually, it was a carrot seed. I learned that from Thad. Well, it's pretty cool. All right. So, more substantive basis. All right. Let's see. Okay, so our basis in modern SI scientific notation are the meter length, second, time, kilogram, mass, the ampere, which is current, measure of flow of charged particles. Current, Kelvin, we use big K because it's named after somebody. Kelvin, just temperature. Okay, and then we have the mole, moly. Hold on, which is it is expressed in, I think, just MOLE. Yeah. No, it actually is mole. All right. Amount. And then the candela, which is a measure of luminous intensity, which is literally still based upon the human viewing a candle. Was it like a British sperm candle according to the Wolfram Alpha? I think they used the blubber from sperm whales or something. I don't know. All right. Our bases. 1 SI are the meter, second time, kilogram, mass, ampere, current, Kelvin, temperature, mole, amount, and the candela luminous intensity. Alright. Okay, we should have something before that because that's a little. We explore the history of units and that transition from human-based measure to a more substantive basis. Through human history, units have come and gone, and as our ability to measure things has increased, our definitions of units has been revised. All right. These currently accepted units have now, since 2019, been directly based on constants of nature. Okay. I say that because that's technically true, but the candela still bothers me. I'm sorry. Personally, I think we can get down to 5 because I've seen Thad literally recreate 288 constants of nature using 5 bases. And there's also, I think, a pretty strong argument why we should use charge instead of current. Because charge is basically just time current. Or, what is it? Charge is technically, it's current divided by time. So you could do it either. No. Current is charge divided, hold on. Charge divided by, oh, I'm in a notebook. Derp. Let's just do this. Yes, that's it. Say Planck charge divided by Planck time. Oh yeah, enable dynamics. There we go. Boom. QP divided by TP. Okay, so that's current. Okay. So either you got to multiply that to get it. I just think charge might be a little bit more fundamental. That's all I'm saying. And technically the fine structure constant is elementary charge divided by Planck charge all squared. So if that's an important dimensionless constant, that might be a good way to think about it. But that's not the part we're at right now. So I apologize. I know. I'm getting ahead of myself. Just need to finish on doing the actual history. It has been directly based on constants of nature. So in the first half, in the first half. Second half of our investigation, we will look to see how we may extend the current Wolfram physics project schema to we will look to see how we may to incorporate such values, such dimensions of reality. Okay, so Stephen might have an issue with that, but that's fine. Let's just get this rough draft out here. Okay, so let's go down. Let's do a new section. All right, I know I'm terrible. Hey, Dan, good to see you, K-Shell. Good to see y'all. Yes, I'm currently mostly just doing this because this is stuff I have to. Okay, save. That's the one thing everybody tells me. It's just that save regularly, save often. Let's save this to the cloud too, because I'm using a whole bunch of different notebooks. I don't know. I have like online mathematics. I have a Wolfram notebook. I have like this. I think this is the complimentary one they gave us for the school. Excuse me, the school. The chat notebook is actually really kind of cool. Let me close this. No, we'll keep that there. All right. Sorry. I know. So many windows, so little time. But actually, okay. I'm sorry. I get very easily distracted. All right. Units. We got here. We got here. All right. Okay, that's a question, so we're gonna need some text. All right, so let's do some outlines. All right, so human-based measures. Okay, so we're gonna do so Egypt, cubits. Okay. So for our friends at Wicked, hold on. I'm sorry. Let me do this. Let's see this way. Oh, let me stop that screen. Let me do the dangerous thing. I'll share the entire screen. Here we go. All right, because we're feeling. Yes. All right. So let's see. All right. Cubit is an ancient unit of length based on the distance from the elbow to the tip of the middle finger. It's primarily associated with Sumerians, Egyptians, and Israelites. The cubit found in the Bible regarding Noah's Ark and of the Covenant, blah, 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 tabernacle. He was divided into 6 palms, all right, times 4, 24 digits. Royal had a palm for 7 palms, okay, 28 digits. Okay, average range, okay. So where are our citations? All right. Definition of a cubit. Okay, it's literally from the dictionary. Merriam-Webster.com. All right, that. Okay. So. All right, so let's go down further. Let's do ourselves a little. Hold on. Let's. All right. Hold on. I'll do another section. All right. Sources. Qubit. Well, that's easy enough. Last time I checked, the dictionary was a source. All right, where are we? All right, let's go back. I'm sure I'm the only one that ever goes to Wikipedia and then trust but verify. Okay. Okay, so that was 1. Where the heck was 2? Okay, so let's see that. It's a drawing. Okay, it's just linking to another Wikipedia article. Okay, that's not overly useful. Oh God, Stephen Skinner's Sacred Geometry. Is this a source we want to use? Oh, it's just linking us back there. All right. Okay. Loosely organized states, the Akkadian Empire. Oh, Sargon strikes again. All right, let's see. Multiple standards, a few agreed upon. Which is just a plethora of multiple standards, a few agreed upon groupings. All right. Cubit. Hands. Feet. And then somebody told me somebody brought like building a bridge in like the 30s or something, and he literally used, I think it was about like 5'7", so he literally used his own height to define the bridge. I thought that was kind of funny. So it's oh God, was this? No, it wasn't a Sterling. It was something else. I don't know. I could look it up. I don't think it's for the scope of this discussion. All right, caffeinate a little bit. Okay, the standard cubit, the big cubit, the rare cubit of the king. Wow. Dang. It's equal to 1.5 from feet or 6 pounds. Wow. Wow, the legal cubit, the black cubit, the king's cubit, the cloth cubit. Wow. let's do this. Let's change this to bullet points. Oh, jeez. Hold on. No, I need to. Because I am bad, let's just do this. We'll move this over here. We'll put our thingy there. Alright, then we'll put this in this cell here. Human-based measures. So now we can do bulleted items. Alright. And go with a qubit. And 8. Fans. All right. Yeah, I mean that's true. That's true. Yeah, we still use hands to measure the height of a horse. That's interesting. You see a lot of the stuff going back and forth. It's yeah. All right. Cool. All right. Human-based measure. Issue. Many were based on Pharaoh. God, I can't spell Pharaoh. There we go. Go spell check. Where's it on Pharaoh / Regent and would change when a new leader came to power. Generally length of forearm to tip of middle finger. Okay. There's the hand. And let's just do this. Units. That's where I can spell. And it's the non-SI unit. Oh, imagine that. Standardized to about 4 inches. Okay, it's used to measure the height of horses in many English-speaking countries. All right. Including Australia. All right, equestrian Australia, measuring rules. Where's the best sources? A complete guide to horsemanship. How big is a hand? Okay, okay, this is from an archive. Well, this is from the Wayback Machine, so measuring rules. All right. How tall is the horse? The hand measure was 4 fingers wide at one time. Now this 4 fingers is a thumb wide. Okay. Okay, so yeah, that's normalized to about 4 modern inches. Okay. And source thing. All right. Let's not dilly-dally on this too much. Let's see. Yeah. The unit foot. Let's go. Historical origin. Let's see. It's typically about 15.3%. People to pass. Preferred the qubit. Alright. Rome, Greece, and China. Okay, over the phone. Let's see. What is this? Measuring the hyphen well. We get an archive here. Let's see, is it original? I mean, that's a little dubious. Numbers of measures. Let's see. Where are we? Okay, continuing on. We got that. The foot. Still used in modern times. Let's see. I know I'm not very entertaining right now. All right, so let's okay. Obsolete feet. I love it. Okay. So, all right, let's continue. All right. So we need to continue onward. So I'm going to need a layout. Where are some of the other ones? Let me check. Okay, where are we? Okay, qubits, imperial feet and hands from England. Yeah. Let's just say we had the metric system. All right, so let's go over to the metric system. So I believe it was originally based on water, which is kind of cool, especially on a hot day, assuming it's hose temperature. God, remember drinking out of garden hoses. Jeez, how do we survive? Yeah. Okay, why did it just rename this? Why did it just rename my... Okay. Is this why I lose all my files? File. Save. I'll save as WSS units project 6/27 2020. Wow, does it just automatically rename? Is that why I lose everything? Okay, see, now it's being nice. Okay, file, save as. Okay, I'm gonna copy it. No, I'm copying you. File, save to cloud. Why can't it just take my title? It doesn't like the periods. Okay, save. Oh, it totally has the ability to do that. Okay. I'm gonna go with gremlins. All right, that's what I'm sticking to. Okay, so hands and feet. Let me See what else. All right, so a metric system. Let's flop over here. Oh my God, he's going to Wikipedia. Here's the thing. Number one, Professor Moser back in the day told me Wikipedia was probably a pretty good thing that maybe you could use to at least start your search. And then when I watch Wolfram working sessions and people for first level analysis just check Wikipedia, mostly for science things. If you want to look for politics, yeah, nobody would ever change that. But then again, that can happen for science too. Tend to, in my opinion, a lesser effect. All right, the metric system is there. All right, option. Most countries in the world, we still use imperial in the States here. Okay, I learned the prefix tera, giga, and mega from Final Fantasy VII because Bahamut's Mega Flare, Neo Bahamut's Giga Flare, Bahamut Zero's Terra Flare. Yeah. Always the best way to learn is from a video game. Okay. Let's see. She was introduced in France. Culminated. All right. Oh, God. I've been saying this wrong. I've been off by a factor of 10. I've been saying it was the Norfolk of Paris divided by 1 million. It's 10 million. Jeez, I was off by a magnitude. All right, I need to. Nobody corrected me. Yeah, now it's designed as, or defined as 1. I'll divide by the speed of light. Da-da. 1 cubic, okay. Decimeter of water. Oh. Oh. Oh, that makes sense. Okay. Okay, put a new cell here. Just to emphasize. Often disagreed upon, combined with human lifespan changes, caused much confusion. Yes. Unlike in Monty Python, when there was much rejoicing, there was much confusion. All right. Cool. All right. Again. Save. Save like your life depended on it. All right. Okay. So. Let's go to standardization. All right. So. New section. Standardization. Okay. Let's call this element of the metric system. All right. You want to talk about arbitrary things? All right. All right. Let's see. Where do we go? All right. The 1790s. Wow. 1700. Yeah, that's after 1776. Okay, mole per second. The moles! All right. Okay. Let's just go for allows for prefixes to express exponential powers. I.e. good for very big or very small measures. All right. So let's do this. All right. So let's actually no. Meter. This one is based upon the meter, which is France in the 1790s. It culminated in the International System of Units SI. System International, I believe. That's how they refer to it. Yes, yes, all the chaos. Let's see. Okay. Originally defined as the distance from the North Pole to the equator by root of Paris divided by 10 million. Yeah, you don't get much more arbitrary than that. Okay, so that's originally. Okay, and then okay. Now defined as 1 over the magnitude of c, speed of light. Or 1 over 299,790. Where is it? 92. I always forget the 2. 458. 458. Okay. Okay, that's on the committee of length. It's modern. Let's see what else we got. Extensibility, base. I know. I'm so full of energy. Look at this. Oh, look, coherence. I've seen this before. F equals ma. Energy equals force times this. Energy is power times time. Oh, and they don't even have a warning on this one. How dare they? The other unit after that I'd start talking about, just they just there was some warnings there, and again, maybe that's just. No, that's it. I'm sorry. I need a tinfoil hat, don't I? There we go. Oh, excuse me. We haven't used tin in a while. It's aluminum, don't you know? Alright, so where was the meter? Uh, 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 hold on. Let's just go to meter itself. Oh, no, sorry. Force a habit. Meter. Yes, yes, we spell it differently because America. Alright, a second with a second is defined by the hyperfine transitional cesium. Yep. And then they use krypton. Alright. Okay, where the heck is the source in this? That's. Hold on. Oh. Let's see. Meter. Is really defined. Yeah, where's the citation? I mean, that's what everybody says, but where's the source? Hold on. Let's go back. Let's check out the history. There we go. Okay. Well, we'll get back to that one. It's not. All right, so let's go back. Adoption. Hold on, where are we? Units. Okay. All right, so let's go to the second. Second, which was I should put spaces here. Because that's sorry, it's hard for me to read. If it's hard for me to read, then who else can do something? Chanelli. Defined as one 60th of a minute. A minute is 1/60th of an hour, and 24 hours in a day. Horses in a day. Earthly convenience. Okay. You're looking at like 10 million there. I think SNL had a great bit. It's like, here are our units. You're like, how the heck could we even science? But somehow, the transformations allow for us to do cool stuff. Okay, and again, this is approximation. Let's see. All right. Sacagawea. $1 coin. Ooh. All right. Oh, this is cool. All right. So we'll get to that in just a few moments, my friends. All right. There's so much I need to do this weekend. I apologize. Let's see, being 2 millimeters shorter than the true distance on the meter originally, all meter measurements till 1883 carried this error. Now, was it based upon that, or because I know they have updated and stuff? Because Dad's even told me, it's like, yeah, as we get better measurements and stuff over the time, we tend to change that, or it keeps being updated as the most recent version of different stuff. Pardon. All right, so now defined as the go to the second. It's the inverse for 1 over the frequency of cesium 133. Put a dash after cesium. No. Oh, I totally spelled it wrong. Or is that a UK spelling? Okay. Cassium. Looks like Cassium to me. I'm such a stupid American. Hey, at least we got the U out of color, right? Okay. Alright, so let's get down to the kilogram. Kilo. Derives from the older meter kilogram, the MKS system. So the definition of the basics that change over time today are defined by physical constants, not by prototypes like that old iridium or platinum bar that we had for years just sitting in Paris. Okay, kilogram. All right. Kilogram. All right. Originally defined by 1 deci. I always forget about the deci. Because you always have meter and centimeter, but there's a deci. That's supposed to be 10. All right. By deci meter cubed on decimeter cubic. decimeter of water. Alright, save. Realizable today, Nisha is accompanied by a practical realization of this. One way the unit can be measured, where possible, this. Okay, what is that? What the heck is that? Oh God! It broke! The International Bureau of Stuff and Things is broken! Not actually the International Bureau of Stuff and Things. Alright, da-da. Cubic deciliter of water. Oh, this is what Rick's been talking about a long time. Of water. For degrees Celsius. All right. And by a man made iridium cylinder. Platinum iridium, okay. Platinum iridium cylinder. And when was that? We did that in so meter convention was 1879. Grab our sources. Oh God, where are the sources? Jeez. Okay, we'll go to this one because they're talking about the update. Okay, a lot of folks didn't know about this. I only knew this because the numbers Thad was using actually changed when I was trying to replicate them. Versailles, France. Let's see. Vital human activities. Grand K. Kilogram cylinder. Polished realities from the world's true kilograms since 1889 is to be retired. Okay, so this is from the AP. Let us continue. Alright, so let's do kilogram. Old. To be fair, the new is actually going to be the same thingy. Gram. No. Oh no, help. Alright, so get that, get that. Where was the second? Second. Let's start from the back. Second Battle of Zurich, the second. Wow. Are these significant system of measure? Oh, of course the French Revolution is somewhere in there. So let's just go to NIST SI. Redefinition. Voted on the metric makeover, yes. I thought it was this plague helpful. Oh, God. Automatic fill-in. Totally not a large language model. All right, so let's go to the second. Okay, second. Here we go. The past. Hey, I mean, it's NIST. It's where we're literally getting it from. Okay, so let's, second. Old. Second. No. It's a fascinating history. To be fair, I think this might actually be. From clocks to a new second. Oh, yes. Second would now be defined as a tropical year between two summer solstices. Oh, God. Yeah. Metrology. No, I met Bill. Bill was a metrologist. He was actually. There's so many smart folks out there. I've learned so much from folks at the conference. Dan's here and everything. Between Thad, Rick, different folks at the conference. Oh God, I can't wait to clip out some of those things. I made myself look so silly. It was phenomenal. One fish, two fish, red shift, blue fish. Those that were there, no. Keep calling Gareth Garrett still. My dad's best friends was a Garrett, so I'll go with that. Okay, so we got that. The second. All right, so let's go back here. Oh, geez, isotopes. I've been spelling cesium wrong for so long. All right. Metric system, boom. Let's add the SI, because it's actually based on Planck's constant now. So let's see. And even this, even the folks at the summer school, it's like, yeah, it's based on Planck's constant. Like, because I mean, we got Planck's constant to like 10 significant digits. We had it to 12, and the error was kind of large because even in that 2018 measurements, you're looking at like, yeah, we got good high confidence in 10. So I guess that makes sense. Still, why do we only have those Planck units to about 5-ish? We got 7 with error. You think we might be able to squeak out another digit or two with confidence? I digress. Okay, as a practical matter, yes. Holding. Don't drop the kilogram. Okay. One mass to rule them all. Okay, so, alright. Okay, this is interesting. If we're basing the kilogram on Planck's constant, and we're literally just setting it as a 1, why, why, shouldn't we have more digits for the Planck mass? I mean, this is, or is it one of those things where you have the base of the system? It's, yeah. The Josephson constant. Okay, because we can look at it a bunch of ways. I don't know. It's the measure prior final value of h bar. Okay, that looks about right. Excuse me, of h. The Planck's h bar with 2 pi there. Uncertainty when SI was redefined, this was set the exact value, which in turn defines the other SI units, including the kilogram. The 2019 redefinition of SI. Mind me, we use Discord. Oh, sorry. I shouldn't be showing that. I shouldn't be showing that. I'm sorry. I was communicating with my mentor. Let me just remove this for a second there. I'm sorry. I try to err on privacy, you folks. He just had a newborn, so Hatem is awesome. He was the first guy, and then Nick was driving and stuff. People are so busy, so I really appreciate it. Congratulations. History and working on the what they call it, the hero image SI chart a bit cleaner using Wolfram language this weekend. Suspect I will need most of my I will need the most help starting next week as we look into relationships with the Wolfram model. All right. I'm sorry. I'm checking updates and everything. There's all these announcements. Okay. All right. I think we're good. All right. Hold on. Save again, just because I know I'm gonna lose this thing, and I'm gonna lose. Yes, Bill. Oh, you missed it when I was at the conference. It was crazy. I'm literally there. I was asking a question about galactic rotation and what their thoughts on significance, but people have been talking about redshift a lot. Still kind of tired, and just in my head, I'm like, I'm just gonna tag on redshift to this. What are your thoughts on galactic rotation and redshift? And everybody looked at me like I had 3 heads. They're like, what do you mean? I'm like, how it spins. And Garrett's like, yes, it's like red shift, blue shift. I'm like, yes. 1 fish, 2 fish, red shift, blue shift. And then it's literally from the Cleveland show. It's at that point he realized just how badly he messed up. And at that point I'm like, Okay, thank you. Just walk away. Just walk away. Just hand the mic to someone else. There's still folks in line. What am I going to argue about? I said a stupid thing. Oh, God. Yes, yes, Dan. It was epic. Oh, it was such a good time to be with all you nerds and everything. Um, Anastasia and Shiloh, they helped put on a good show, and I didn't even know, like, they were both, like, horribly sick the entire weekend. I knew Shiloh was sick because he ate the warm shellfish, but apparently, yeah, they were both, like, holding down the fort, and I'm like, oh, their energy seems, I'm like, dang, I barely knew, like, they had, like, food poisoning the whole time. Oh, I hate that. It's such a pain in the butt, literally. All right. Let's see. All right, let's finish this up. So, oh God. File. Save. Where are we saving this again? Cloud. Okay. Now define based on 5 constant H. All right. File. Let's go to the ampere. The ampere, don't you know? Oh, God. It was, Portugal is an interesting place. I still got to write up my little thingy. All right. It's an indispensable, oh, God, the pretty lights. Love hair dryers, okay. Has been an since, okay. Should probably put the dimensions of measure here. There we go. So, length, time, mass, okay, ampere, it's current. The ampere is the constant current which is maintained by two straight parallel conductors of infinite length of negligible circular cross. Placed 1 meter apart in a vacuum would produce equals 2 times 10 to the negative 7 newtons per meter of length. Now, coincidentally, if there was a kink in current or charge, it's yeah, maybe that's okay. We don't need to speculate here. That comes next week. All right. Originally, God, I can't spell it all. All right. Defined as the okay, well, a Newton is force. It's the force between two straight parallel. God, so bad. It's Carell. Wires. Yeah, because infinitely long wires weren't accessible. Wires placed 1 meter apart in a vacuum. Force generated by a constant current times 10 raised to the negative 7. And that's newtons per meter. Newtons over meters. Okay, now how is it? The ampere. I don't know if it's. Oh, now it's based upon elementary charge, don't you know? Really? So our unit of current is based upon charge. Gets the old noggin a joggin'. Okay. Now, let's see. Amount of electric charge in a single electron or proton. But the quantity of electric charge by itself, whether in motion or not, is expressed in another SI unit, the coulomb. 1 coulomb is the current of which 1 coulomb travels against the point by lightning bolts carry blah blah blah. I want 10 billionth of a billionth. I'm going to charge 1 amp in 1 second. All right. It's a sort of good news, bad news outcome. On one hand, defies the amp clearly in terms of only one invariant in nature. The exact things. Okay, the defined measures the amp become a matter of counting the transit of individual electrons. On the other hand, he is. Okay, so what exactly is the measure? Charges in motion per unit of time. Now, defined by E, elementary charge in motion per unit of time. Alright, so, okay, that's going to be charge meters per second. Alright. Let's do a quick calculation. Charge. Like charge. All right. Meters per second. Oh, say. Let's do the speed of light. Magnet pole strength. Oh. Hold on, no, that's not right. Elementary charge. God. That's not right. Hold on. So. Alright, so ampere. Alright, I'm gonna have to get out of here in a few minutes. I gotta go to lecture with Xerxes. So I'll just finish this up and save. But thank you for all joining me. I'm sorry I've been a little scarce. I've been doing some stuff and things behind the scenes and catching up on maybe some major jet lag. Hold on, let's go to ampere. Electromagnetism, blah, blah, blah. $1881. Save as WSS units project 6/27/2025 1. Alright, and then save to cloud. Same thing. And then that means, alright. Update that, update that. Alright. So with that, I actually gotta go peace out, my friends. So, close that, close that. Boom, boom, boom. Alright. So at least I've actually put in stuff to paper, so to speak. Yes, I'm channeling my inner Professor Wolfram now. Because that's what I'm going to try to do the write-up in, kind of in that layout there, and have some clickable things, and just make sure people can follow it. Why? Because it's freaking cool. So, other than that, hey, thank you all for joining. I know I see some more folks there. I'm so sorry. Snacks, Jedi, Morgan, and everybody, but I got to run, and I'll keep you all updated. So, other than that, peace out, everybody. Catch you next time.